Oh, hi there. Thanks for showing up for your learning. It's Mr. Jennings, and today we are looking at our exponent laws, our scientific notation. All right, cool. So we're going to change that. It's going to say scientific notation and powers. All right, so page one, everyone's going to do this page. It's just making sure that everyone has absorbed the basics of exponents and scientific notation. So let's take a look. We're going to want to be able to use the proper terminology, the proper vocabulary to talk about exponents and powers. So the base is like the bottom, the main level of the exponent. It's the thing that gets multiplied repeatedly. The exponent, and so we'll call this the base. The exponent is the number that tells you how many copies of that thing we're going to multiply by. So this is the exponent. Okay. And then if we're talking about like what is a power, well, power means a lot of things, but certainly math and knowledge is power. But in this case, we're referring to the whole unit. This would be a power of z. Okay. Later on, we'll find out that z is -5, so it will be a power of -5. Okay, and then, well, what does that leave? What's left? And the only thing that's left is the coefficient. So the coefficient here refers to any number that's multiplying a variable. So if you break this down Bedmas style, you'll notice that this 2 is multiplying the z, but the z is already being multiplied by itself 3 times. There's 3 copies of z that are multiplying. So that when I write this out this way, 2z to the 3 is equal to, well, I could do expanded form, right? 2 times z times z times z. That would be expanded form. And then I could also write that as 2 multiplied by -5 times -5 times -5. Okay? Or I could have just written that from up here as 2 to the -5 in brackets to the 3. Okay? Notice I'm always substituting into brackets, very nearly always, because it's a very good habit. All right. So these are some things that are true, but we want to evaluate that. So maybe I do 2 times -5, and that would be -10. And then I'm going to multiply that by -5 times -5. And then maybe I multiply by the next -5. That would give me +50. But I still have to multiply by the last -5. And that would be equal to -250. Okay? Or maybe I just looked at it and I was like, look, I got 3 negatives. I know the answer will be negative. 5 times 5 times 5 is 125, and 125 times 2 is 250. So it's -250. And that's it. That's all. Okay. Next skill. Next skill is we want to be able to look at a number in scientific notation and really let that we want to be able to write it in standard notation, know what it means, know how to interpret all the little bits. Number in scientific notation is like a little Bedmas puzzle. All right, let's go. So I want to write these from least to greatest. So I'm going to go ahead and just like visually look down the list and figure out which one is the least. This one here is the least. How do I know that? It's the only negative one. Negative numbers are least. On the actual test, I'm going to change this from greatest to least because I don't like numbering them like least is weird. Okay, greatest should be up, but that's arbitrary. It doesn't matter. Okay, so the least would be 1, 2, and then I've got to take this decimal point. Okay, this decimal point here, and I got to shift it 3 to bigify the number. So I'm going to go from here. That's trademark, by the way, bigify. All right, so I'm going to 1, 2, 3. Oh, but I needed to create 2 more zeros to get that in. So that's basically just the number 1200, but it's negative. Okay. All right, next. So what's the next smallest one? Wow, 5/10,000ths. What a weird way to write a number. This one looks pretty small. This has a 0 in it. This has a -9 in it, and I seem to remember something about that -9. Okay, so maybe I'm like, oh, so 5/10,000ths. That would be 5 over 10,000. Well, that's pretty darn small. but actually there's a smaller one. So I'm going to write this one down. It would be 5 times 10 to the minus 4. Why? Because it's equal to 5 divided by 4 copies of 10. Negative exponents mean divide by that thing that many times. And that would give me that number that I wrote down over here, 5 10,000ths. Okay, so that's that goes there. That's that one. 5 times 10 to the minus 4. Oh, but I have to write it in standard notation. Okay, not just in scientific notation. Good thinking, Mr. Jennings, but it's actually 0.0005. That's 5 10,000ths. This one here is the absolute smallest because we're dividing by 9 copies of 10. That is properly small. So we're going to have 8.9, but then I move that decimal place 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we write it that way. Boop. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's already there. And we'll write a leading 0, and that's the number 0. Oh, I'll make my decimal place a little clearer there. Okay, now let's talk about the next one. The next smallest one is this. It's already written in standard form, so hootenay hananay. That's just lovely. 5, 6, 2. It just is what it is. And I can see it's bigger than that because it's way closer to the decimal point, but it's smaller than the next one. The next one is this one here. 1.8 times 10 to the 0. That means multiply by 0 tens. Okay, so it's just 1.8. Oh, okay. And then the biggest one is this one. Yeah. 3, 4, move the decimal place 5 times, 340,000. Okay. That would be correct for all the marbles. That's how expand scientific notation do into standard notation. They are little Bedmas problems. You can just do them. You can even just like type that into a calculator and it's going to tell you what they are. But in many cases, it's going to tell you back that it's that number you just typed in scientific notation. Because calculators like scientific notation. They like to tell you this. So you do need to be able to interpret those numbers. Let's go. Okay. These ones we've been asked to write these in expanded form and then evaluate. So this is going to be 4 copies of minus 5 multiplying. Okay. And then when I do that, I get 625. Okay, you can work out your multiplication yourself. If I've been asked to expand that, I'm going to do this first. 3 times 2 to the 4. 11 minus 9 is just 2. I can still do expanded form here. 3 times 2 times 2 times 2 times 2. And then evaluate that. That's 48. Now, what else to say about that? If you had written this, 3 times 11 minus 9 times 11 minus 9 times 11 minus 9 times 11 minus 9, you are still correct. That's fine. This one here, the trick is to know that it's different than this, because this one, the negative gets called onto the exponent ride. It has a ticket for that exponent ride. This negative is left out of the exponent ride. This is negative 11 times 11, okay? And that's the expanded form for that. I could even have my brackets there if I want. It's the same. And then minus 121 is the answer. Boom. Okay. This one I might expand twice. Maybe I say that this is 3 to the 3 times 3 to the 3. Oh, but I could keep expanding. That's 3 times 3 times 3 times 3 times 3 times 3. Oh, 6 3's multiplying. My goodness, that's 729. Yeah. Okay. All right. Let's go. This one, expanding it. Oh, how do I expand those ones again? Oh, right. So that would be dividing by 5 copies of 5. 5 times 5 times 5 times 5 times 5. Put in my dots so that it's clear. Dividing 5 times 5. Okay. And so that would be equal to 1 on 5 times 5 times 5, which is equal to 1 on 125. Done. Okay, cool. Let's go. Oh, things got spicy fast, eh? Well, this is an idea. I say it's spicy, but it's not hard. It's just people don't think about it. And if you're thinking and doing math, then you're doing something right. And so maybe that's not spicy, but it's just good. Okay, so if we know that there's 100 or 10 to the 2 centimeters in a meter, and that there's 1,000 or 10 to the 3 meters in a kilometer, we want to know how many centimeters are in a kilometer. Okay, so that would be the same thing as saying, like, that would be 10 to the 3 meters in a kilometer multiplied by 10 to the 2 centimeters in a meter. That's going to be 10 to the 5 centimeters is equal to 1 kilometer. All right, cool. But what if we were doing area? Okay, and this one I want to like pop over to some blank pages here. Okay, so suppose I have this area here, which is a meter squared. All right, that's 100 centimeters. That's 1 meter equals 100 centimeters. And so a meter is 100 centimeters. That's simple. But if I'm going to find out the area, that's like, you know, how many of these little squares? There's 99 lines that way, or 100 rows, and 100 columns. 100 rows, 100 columns, we have to multiply here, right? So to do the area, like 1 meter squared would be the same thing as 100 centimeters squared. But we can use powers of 10 here. That's 10 to the 2 centimeters squared. So that's going to be, well, that's 10 to the 4 centimeters, which is actually 10,000 centimeters. Oh, centimeters squared, sorry, because each one of these is a square centimeter. Okay, so when we have like units that are multiplying to do area or volume, we also have to square or even cube that conversion factor. That's a popular trick that they'll play on you on the SAT test. Okay, so here, if we go back, all right, I know the 1 kilometer squared. Well, here, this would be 10 to the 3 meters, but I got to square that. So that's going to be 10 to the 6. Oops, that's weird. 10 to the, multiply the exponents, in this case, 6. So this is going to be 10 to the 6 meters squared, is the same thing as 1 kilometer squared. And then I already know that there's 10 to the 5 centimeters in 1 kilometer. So if I take 10 to the 5 and I square it, then I would get 10 to the 10 centimeters squared. Okay, cool. So that's how you would do those conversions. And now let's go to volume. Volume's the same, but we have to cube these things. Okay, because if I go back to my blank pages, now we're talking about, like, say we had a box and it's a meter by a meter. It's a very large box, but it's like still like 2 people could pick it up. 1 meter by 1 meter by 1 meter. Okay, and so that, when I cube that, is 1 meter cubed. Cubed things measure 3D space. Okay, but each one is equal to 10 to the 2 centimeters. So 1 meter cubed is the same thing as 10 to the 2 centimeters all cubed. So that would be, multiply the exponents in this case, 10 to the 6 centimeters cubed, or 1 million cubic centimeters are in this cubic meter. Okay, and that's significant, so we want to write that down. But here we got meters cubed, and I know that there's 1,000 meters, so that's 10 to the 3, and I have to cube that, so that's 10 to the 9 meters cubed. And then over here, I know that there's 10 to the 5 centimeters in a single kilometer, but I have to cube that, so that's 10 to the 15 centimeters cubed. And now, let's just go ahead and see if Google agrees. Okay, so I'm going to go over here. I'm going to get a fresh Google, all right? And I'm going to say, convert 1 cubic kilometer to cubic centimeter. Yeah, it says 1e plus 15. And we've seen this format before. This is scientific notation in another form. Okay, it's just telling you 1 multiplied by 15 tenths. That's what that e plus 15 means. It's just a different way of writing down that. So, yeah, there, you'll see it there. Boop. Again, e plus 15. Not my favorite way. I prefer to write down my 10 to times blah, 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 but whatever. So we were correct. I was correct. I knew I was correct, but I just want to, show you that this is something you have to do if you're changing your conversion factors. Okay. All right. Next topic, everybody. We are going to evaluate these divisions. Okay. So this one here, and I want to do this. I want you to do this without a calculator showing your work. That way I know that your thinking is good about exponents and you can apply your exponent laws to scientific notation situations. So I think about this as 6 divided by 3 multiplied by 10 to the 5 multiplied by 10 to the 3. Okay, 6 divided by 3 is 2, and that works just like division. Okay, 10 to the 5 divided by 10 to the 3 is going to be, when we are dividing powers of the same base, we subtract the exponents. So this is 10 to the 5 minus 3. And so that gives me 2 times 10 to the 2. And expressing the answer in scientific notation, I'm already ahead of you, but I could also write that as 2e plus 2. But this kind of makes me want to barf a little bit into some kind of bucket. Like, I don't particularly love that notation. It's fine, but I would write it down that way every day of the week. Because that's a Bedmas puzzle. This is special notation. That's why I teach you this way, and you want to know that way and just be able to read that. Okay, circle your final answer. Okay, here, this one's a little bit more medium. So here we go, 4.8 divided by 9.6. I happen to know 4.8 times 2 is 9.6. So I could rewrite this as 4.8 divided by 4.8 times 2. Okay, so that I get cancel, 1 on 2, multiplied by 10 to the 11 minus 8. We're going to subtract the exponents there. And then if I've got 1 on 2, well, I'm going to use the decimal expansion for that 0.5 because we're working scientific notation here, folks. And that's going to be multiplied by 10 to the 3. Oh, but that's not correct scientific notation. I really want 5.0 times 10 to the 2. What happened with my power of 10 there? Well, if you notice, 0.5 multiplied by 10 is equal to 5.0. So I basically used one of these 10s. I borrowed a 10 from there and multiplied that thing to bigify it so that this would be my correct answer. 5.0 times 10 to the 2. If I expand that, that's just 500. Okay. This one here, you can also do some tricks. Let me show you some tricks. I'm going to borrow 2 10s from the top, okay, to multiply that 1.32. Okay, so that's going to be equal to 132 times 10 to the 1 because I borrowed 2 of them already. And then on the bottom, I'm going to borrow yet another one, okay? So I'm going to have 55 times 10 to the minus 5. This is a good point where if you're working on this question and you don't understand what I've just done, that's a good question to bring to me. Say, Mr. Jennings, can you explain that a little closer? Because there's a lot going on in these spicy questions that's just a question of fluency. It's just me moving numbers around and making it convenient for myself so that the math becomes easy. And I want you to learn those tricks, but you need to tell me the tricks you want to learn. And you need to bring that question to me. That prepares your brain for learning when you bring me a good question. Okay, so definitely do that. I really appreciate it when you do that. 132 is the same thing as 11 times 12. And 55 is the same thing as 11 times 5. And then I've got times 10 to the 1 minus 5. Okay, so this cancels, and I've got 12 divided by 5. 12 divided by 5 happens to be 2.4 multiplied by 10 to the 6. I think that's right. Let's see if I'm right. I mean, and then this is what you can do when you're working on your own, right? Is you can check your answers, and you just check your answers in Desmos like this, like Desmos. This is a great tool to build your math learning. Okay, so I'm going to have, I believe it was 1.32 times 10 to the power 3. I think it was 3. All divided by 5.5 times 10 to the minus 4. Oops, no, that's to the 10 to the minus 4. That's all wrong. It's like, oh no, I have a huge error. No, I don't. 10 to the minus 4. Okay, so let's see. Did I get the question right? 10 to the 3, 10 to the minus 4. I said it's 2.4 times 10 to the 6, or 2,400,000. 10 to the 3, 10 to the minus 4. 10 to the 3, 10 to the minus 4, 2,400,000 is correct. Okay, so check your answers in Desmos. Desmos is nice because you can see the whole expression. You can edit it. If I change something in here, it will change the answer as I go. You see, like it's changing. And that's nice. Oh, that's a neat number. It's a lot of 2's. 2.020202020. I bet that pattern continues. What's going on there? That's super cool. Something to investigate for someone who's interested. Okay. All right. Let's go. Where? Okay, let's go. All right. Evaluate without a calculator showing your work. Again, because I want to see that you can work with these expressions and apply your power laws without just cranking it on a calculator. So this one I like to regroup, okay? 3 times 2. So because we can multiply in any order we want. So this is 3 times 2. I've done that one, I've done that one. Times 10 to the 3 times 10 to the minus 1. Okay? And we don't get confused with these negative exponents. We just apply our laws stubbornly. And because we know how to add and subtract positive and negative numbers, we're going to say 3 times 2 is 6. 10 to the 3 times 10 to the minus 1 is 10 to the 3 plus negative 1. And if we add a decrease to 3, we're going to go down. That would be 2. That's 3 minus 1 is what that means. So this is 6 times 10 to the 2 equals 600. But we were asked to give our answer in scientific notation, so that's what I want you to do. Okay. This medium one here works the same way. It's just slightly weirder numbers. It happens to have one of my favorite numbers buried in it. 1.7 times 2 times 10 to the 13 times 10 to the 21. Cool. Okay, so 1.7 times 2 is 3.4 multiplied by 10 to the 13 plus 11. Oh, that's 3.4 times 10 to the 34. And that's a little clue from your math teacher that you were right. Okay, sometimes I like to bury cute numbers in there for you to find and say, that's got to be it. But don't think life's going to do that for you. Okay, you just, like when you get a weird looking number, that may very well be the correct answer. Okay. All right, here, same thing. So this is equal to 8.2 times 1.5 times 10 to the minus 2 times 10 to the minus 1 is equal to 8.2 times 1.5. Gets bigger by 4.1, so I add 4.1 to that. That's 12.3. That's my cute number there, 1, 2, 3, multiplied by 10 to the minus 3. Okay, but I want to smallify this to get it into proper scientific notation. 1.23 times 10 to the, well, I just divided by 10, so I should multiply by another 10. So that would be divide by 1 less 10 there. So my exponent will go up by 1. That's 1 more 10 up there. Okay, and to show you that it's true, 1.23 times 10 to the minus 3, sometimes like I just really want to show you. So 12.3 times 10 to the minus 3 is the same thing as saying 2.3 divided by 10 times 10 times 10. Divide by 3 copies of 10. Okay? Now, 12.3 could be written as 1.23 times 10. Okay, that's the same. This is the same. It just shifts the decimal place. Divided by 10 times 10 times 10. Cancel, cancel. Oh, I'm only dividing by 2 tens now. So this would be the same thing as saying 1.23 times 10 to the minus 2, which is what I gave as the answer. And it's what you're going to give as the answer because you're watching this practice quiz. And you're like, oh, I got this now, Mr. Jennings. Thank you for this 15th explanation of these ideas. I really appreciate it for me when you explain it for the 15th time. And I say, no worries. And if you need a 16th, come ask. Okay, never be shy to ask someone to explain things for the 16th time. Some lessons take a little while in the learning. Okay, so this one we've been asked to simplify. You do not need to evaluate. Okay, here I multiply the exponents. So this is 2 to the 6 times 2. This is 2 to the 12. Okay, and if I was ever confused, I could expand. That would be 2 to the 6 multiplied by 2 to the 6. Okay, 2 copies of the base multiplying itself. Oh, here I remember that's 6 copies of 2. That's 6 copies of 2 together, 12 copies of 2. 2 to the 12. Circle it and love it. All right, this one, 6 to the 4 times 6 to the 6. Again, I could do 6 times 6 times 6 times 6. Times 6 times 6 times 6 times 6 times 6 times 6. Someone shake Mr. Jennings, he's broken. Okay, that's 6 to the 10. 10 copies of 6, because here we add the exponent. 6 to the 4 plus 6 is my exponent. 10. And you can remember by expanding, this one is 4 to the 6 minus 4, which is another way of saying 4 to the 2, which is, you can evaluate that. That's 16, which is the number of times I've explained this. Okay, and you can expand as well. Never be shy to expand these things. 4 times 4 times 4 times 4 times 4 times 4 divided by 4 times 4 times 4 times 4. Cancels those 4, cancels those 4. Only left 2 upstairs. That's 4 to the 2. That's the answer. But what if we got stuff like that? It got medium fast, boys and girls and math people. It got medium fast. Okay, so yeah, I know. I wanted this for my spicy level, so I had to put this as the medium level. No, this is you should be able to do this after a little bit of practice. It's just like, okay, I do this as negative 12 times 2, that's negative 24. Y to the 3 times another y, that's a y to the 4, because this is y to the 1, and we got an x there, so that's just x. Xy to the 4, done. That's it. It's not that bad. Okay, this one is I raise everything in there to the powers, so that's 3 squared times x to the 8, because we are multiplying exponents, folks. Y to the 6, but simplify. Okay, so we're going to simplify that 3 squared at the medium level, okay? That's 9x to the 8, y to the 6. That's done. Why didn't I evaluate them over here? Oh, because I gave you 6 to the 10. I don't want you to multiply that out. Like, you would need a calculator. I would use a calculator. Let's use a calculator. See how big it is. It's going to be like plenty bigger than a million. Well, it's way bigger than that. I'm guessing it's like between 10 and 100 million. I don't know. 6 to the 10 equals... between 10 and 100 million. There you go. Yeah, boom. Okay. I didn't even bother to memorize it. I can't imagine 6 to the 10 ever coming up again. Okay, here. This one we divide. So 8 divided by 4. This is just divide, okay? You just do it. It's just divide. So 2. Okay, there's 2 4s in 8. And then x to the 4 over x to the 8. That's x to the 4 minus 8. Y to the 4 minus 5. That gives us 2x to the minus 4. Y to the minus 1. oh wait, I remember I can write that as divided by x to the 4 y. Okay, and that's correct. You just want to put your positive exponents. This is correct. I probably don't take a mark off there, but I might come and chat with you. Hey, can you use positive exponents next time, please, so I don't barf in that bucket again? Okay. All right. People know what I mean by it. Like, you don't make me actually want to barf in the bucket. There have been a couple times where people have told me math things that have been so gross I have felt nausea, but I've never actually barfed. But it's when someone has it correct, but they insist on doing it in a weird or gross way that I prefer to avoid. And things like mixed numbers, blah, youch. Anyway, okay, let's go. Here, we can do this. We can do this, folks. We can do it. Okay, so I'm going to do the power first, but there's a few ways that I can go about this, but I'm going to do the power first. So that's a 3x squared y to the minus 3. Gross. Okay, 2 cubed x to the 9 y to the 3, because I'm multiplying exponents, and that's y to the 1. So there's 3 copies of y multiplying, 9 copies of x multiplying, and then they're all going to multiply by those, like negative 3 copies of y, which is like division and stuff like that. And then we're just going to copy this, 12x to the minus 2 y to the 3. Now let's do this multiplication that exists up here. Okay, so I've got 3 times 8. 2 to the 3 is 8. Okay, you want to be able to do that. Okay, so that's 24. X to the 2 times x to the 9 is x to the 11. I just added the exponents, folks. Y to the minus 3 times y to the 3 is no copies of y left. So it's y to the 0. Because 3 minus 3 is 0. Notice I didn't write down y to the 0, because that would be the same thing as multiplying by 1. So I just leave it out. Okay. 12x to the minus 2 y to the 3. We're just going to write that. 12x to the minus 2 y to the 3. Okay, let's keep that. 24 divided by 12 is 2. X to the 13, because I subtract negative 2, and that's adding 2. Y to the 3 can stay downstairs. It's fine. Simplified. Correct. Final answer. Okay, now some word problems. All right, so here's a mild one. A house, it's doubling in value every 10 years. Every 10 years it's going to double. This is an increasing relation. So you can write a sentence like this. Since the house grows in value by doubling every decade, it is an increasing relation. Time and money, time and the value of the house are related. The further time goes along, the more the value of the house grows. So, it's an increasing relation. Okay. How much will the house be worth in 2054? Okay, well, let's find out. Okay, so we're going to go 2054 minus 2024, because we are asking this question in the year 2024. If you're watching in the future, hi, I hope everything worked out. Okay, 30 years. And it doubles every 10 years. So I'm going to do 30 divided by 10 equals 3, little power of 10 magic for you there. So it's going to double 3 times. So I can do this. This is actually kind of a medium or spicy way of writing this down, but if you just double that 3 times, you've got it, right? You've got it. And then adjust your scientific notation, or just give me the answer as a dollar, as anyone would. Okay, but anyway, so now I can write this as the cost, which is 7.5 times 10 to the 5. That's the price of the house today. And I'm going to multiply it by 2 3 times. That's why this is on the exponents test, is because doubling something 3 times is like multiplying by 2 3 times, which is 2 to the power 3. So then I know that that is 8. This is 8 multiplied by 7.5 multiplied by 10 to the 5 Those are all those elements. 8 times 7 to the 5. Well, that would be, let's see, let's double it once, 15. Let's double it twice, 30. Let's double it another time, 60. So it's going to be $6 million. 60 times 10 to the 5. Okay. Well, that's 6.0 times 10 to the 6. Oh, I did it again. I buried those little numbers that give you a clue that you're on the right track again. Okay, so now I write down, so this house that is only worth $750, 000 will be worth $6, 000, in 2054. So that's why you got to get in the real estate game, folks, because it's doubling every 10 years. That's actually not necessarily true. No, it's not. But if it were, that would be a good way to invest your money. Good, but not great. Doubling every 10 years is good, but not great. Okay. All right, let's go. Okay. All right. Some astronauts are flying in space. That sounds cool. Mr. Jennings, thank you for making an effort to make this cool. Oh, no problem. All right, so fill in the chart. Oh, Mr. Jennings, that's not cool. No, don't worry. I'm sorry. All right, whatever. I'm not that sorry. Okay, 3 times 10 to the 13. So that's 3. And then I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's a lot of zeros, Mr. Jennings. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's a long way. That's like different galaxy, I think. Gosh, that's dumb. That's so far away, it's dumb. Okay, all right. So now, that's how far that one is away in kilometers. This one should have a little km there. And I want to write that in scientific notation. So I see, well, I'm going to move this 3, 6, 8. I move that 8 times. So that's 3.4 times 10 to the 8. Oh, what about these two? Helsinki is 20 times further from the sun as Nairobi. I see what you did there, Mr. Jennings. That would be 3.4 times 10 to the 8, because I figured that out, multiplied by 20. Okay, so, well, multiplying by 20 is the same thing as 3.4 times 2 times 10, that's the number 20, times 10 to the 8. Okay, that's the number 20, 2 times 10. 3.4 times 2 is 6.8. 10 times 10 to the 8 is 10 to the 9. So I'm going to write that down, Mr. Jennings. 6.8 times 10 to the 9. And yes, you could learn to do that in your head. So I can use this for reference. That's going to be 6,800, 000, 6,800,000,000 kilometers away. These are dumb numbers. I could have taken 2 zeros off of all of them and it would have been way more interesting. All right. Bogota is 500,000 kilometers closer to the sun than Nairobi. Oh, man, Mr. Jennings. Okay, so I got to subtract it. I'm going to subtract it from that. It's much easier. So that's 3,4,000,000. Is that what it was? 3 million? No, 300 million. 34000. So I got a comma there, and a comma's there. All right, and then I'm going to take away that. Gives me, borrow here, 3395000. Okay, 3395000. Okay, 3395000. Oh yeah. Okay, and that is 3.395 times 3678. 10 to the 8. Notice that this number and this number are extremely close, even though we took away 500,000 kilometers, because those numbers are just so big. Okay? And so that's how far away from the sun they are, this far. Okay, so I just filled in the chart. But I'm done. Okay, which astronaut is Tokyo closest to? So Tokyo is so friggin' far away. And the furthest one away besides Tokyo is Helsinki, because this number be biggest. And I want to know the difference there and how far away they are. Okay, so I'm going to go on my scratch paper. 3. Oh, wait, this is too many. 3 times 10 to the 13 minus 6.8 times 10 to the 9. 3 times 10 to the 13 minus 6.8 times 10 to the 9. Okay, this whole thing could be written like this. 3 times 10 to the 4 times 10 to the 9 minus 6.8 times 10 to the 9. I made this question up a few years ago, okay? Forgive me. I wouldn't play it this way anymore. Okay, I'm just going to make the decimal place in the same spot. Okay, this is properly, like, spicy, okay, to do this calculation in this way. So hang with me here. 3 times 10 to the 4 is 3 with 4 zeros multiplied by 10 to the 9. That's the same thing as this number. It's just written in a weird way so that I can subtract 6.8 from it times also 10 to the 9. So now I've lined up my decimal place. Right? So now I can do this. So this will be 2, 9, 9, 9. That became a 9, and that became a 0.10. So that's 993.2 times 10 to the 9. And then I move this back 1, 2, 3, 4 there. So this is 2.99932 times 10 to the 13. Mr. Jennings, will I ever need to calculate astronauts in this way? No, absolutely not. But if you can do these types of problems, you've really shown me that you're comfy with scientific notation. And I want you comfy with scientific notation, particularly if you're a spicy student. Okay, let's keep going. So let's write that down. 2.39s and a 3.2. Times 10 to the 13 kilometers. And you could say Tokyo is that many kilometers away from Helsinki. Cool. Let's go. Oh, here's some medium spicy stuff. Great. I love medium spicy stuff. This is the last question? Yeah, it's the last one. Okay. So I remember this. We talked about this in class. I was paying attention in class because I like learning. Good. So let's go, Mr. or Mrs. or person I like learning. Let's go. How many times more populous is Brazil than Hong Kong? How many times more? Okay, so that means if I multiply Hong Kong's population by something, I get Brazil's population. So to do that, I'm going to put Brazil on top, which is going to be 2.03 times 10 to the 8 divided by Hong Kong's population, 7.5 times 10 to the 6. And then, you know, some things you just got to know. That's like calculator time. Notice this one doesn't say don't use a calculator, so this one I encourage you to use a calculator. All right, so I'm just going to do 2.03 divided by 7.5 equals 0.27, so this is going to be 2.771. 2.71. I'll keep the same number of significant digits as there. 2.71 times, and then here it's going to be times 10 to the 1. Okay, watch this. Yeah, it's going to be 2.27 times more populous. Okay, if I take this number and multiply it by 27, it's going to give me Brazil's population. Watch this. Here's a population of Hong Kong, 7,500,000. I multiply that by 27.1, let's say, I get really accurate. I'm going to get Brazil's population, which is 203 million. Okay, I've shown you a few ways how to get these exponents right. So what I got there was this, right? Like when I subtract these exponents, I get 0.271. That's this one here. That's the result of this division, multiplied by 10 to the 2, because I subtract the exponents here. But then I want to move this that way, so I'm going to borrow one of these 10s to do it. So that's my answer. And then I want to give a sentence answer to show that I really understand what I've done, which is Brazil is about 27 times more populous than Hong Kong. Capitalize that. There. And spell populous correctly, Mr. Jennings. There. There we go. How many times more dense is Monaco than Russia? Oh, wow. I got to calculate both of their densities and then compare them. Okay? And I want times more dense. How many times more dense? Okay, so first let's do Monaco, the density, which is going to be people divided by area. So that's 3.84 times 10 to the 4, about 38,000 people living on about 2 square kilometers. 2.1 times 10 to the 0. Notice, I'm just going to write 2.1. People usually write 10 to the 0. Okay? All right, and that's going to be Monaco's, and then that's going to be equal to something. We're going to do that in a second. Russia, on the other hand, is 1.44. Oh, man, there's so many more people, times 10 to the 8. Oh, but it's so much bigger. 1.7 times 10 to the 7. Okay, so let's work out what those are with our calculators. We 3.84 divided by 2.1 equals 1.83. Okay, so I'm going to round to that. So that's equal to 1.83 times 10 to the 4. Okay, don't forget that. There's 18,000 people per square kilometer in Monaco. That's a lot more than it's going to be in Russia. Okay, so Russia, way less dense, even though it's way bigger by population and area. Well, it's that area thing. So we're going to go 1.44 divided by 1.7 equals 0.84. Okay? And that's going to be 8.4 people. Okay? Because we have an extra power of 10 there. The 10 to the 8 times 10 divided by 10 to the 7 is just 10 to the 1. So I'm going to multiply this by 10. So I got 8.47 people. Now, we got to take this number and divide it by that number to find out how many more times that one is populous there. So that's going to be equal to 1.83 times, this is what we're looking for is 1.83 times 10 to the 4 divided by 8.47, which is, I got that number there, but I'm going to just clear it. Okay, 1.83 times 10 to the power 4 divided by 8.47. Oh, so it's a little over 2,000 times more dense. Okay, if you have 8 people on a square kilometer in Russia, you've got about 16,000 people on the same square kilometer. But even more than that, it's 18,000 people, as we can see up there. And it's more than 8 people on the square kilometer in Russia. But anyway, so then we say that's equal to 2183, I think it was. 2160.5. So we're going to say 2161. Okay, 2161. Get it correct off your calculator. 2161 people per kilometer squared. Okay, put in your unit. That's nice. And if you just have your unit in your sentence, that's fine too. Oh, wait, no, it's just that many times. It's not. No, that unit is not correct because the units will divide away. So it's just 21.6, 2,161. Stop talking. Just write the answer. Monaco is 2,161 times more dense than Russia. Amazing facts. Amazing facts. Okay. So now, how many more people live in the United States than Canada? How many more, right? That's not how many more times. That's how many more. So we want the difference in the population of Russia and Canada. So I can write the population of Russia as 1.44 times 10 to the 8 minus the population of Canada, 4.13 times 10 to the 7 equals 14.4 times 10 to the 7 minus 4.13 times 10 to the 7. Okay, I can line up my digits in that way and say that it's approximately 14 million people. Sorry, no, 10 million people more. Sorry, no, 100 million people more. Gosh, geez. But I can do better than that. So that was going to be equal to, let's just do our subtraction there. 14.4 minus 4.13. And we're going to borrow there, so that's a 3, and then that makes that a 10, so that's going to be 0.720, 10.27. So it's going to be equal to 10.27 times 10 to the 7, which is the same thing as 1.027 times 10 to the 8. And then have your sentence. There are about 102,700,000 with another comma more people in Russia than in Canada. Okay, that's that. That's how that one do. Okay, so when you go through these questions here, I hope first of all you followed those practices of like try the problems first, see how they go, and then watch the video for the solutions. And then after you did that, then you were like, I'm still confused about this one. I got it wrong and I don't understand how you did it. Then you come to me and you ask that question. That's how you're going to like 100% these quizzes. That's how you're going to 100% these ideas. That's how you're going to get the conversation that you need so that you understand all these tools and you're ready to crush grade 10. You're ready to go into science class. Scientific notation number comes at you. You're like, pow, 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 I got this. And for showing up for your learning, I salute you. Thanks very much for all your hard work on building these ideas, everyone. Bye for now.